Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. And make sure to stick until the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have 2 to the power of 3 to the power of x is equal to 32. So now, the first thing I'm going to do to solve this problem is I'm going to make both of these bases the same. So I obviously want to find the value of x here. So for my solution, first start with 2 to the power of 3 to the power of x is equal to 32. Now 32, if we want to make these two the same bases, I need to change 32 so that it has a base of 2. Well, 2 to the power of 1, this is equal to 2. 2 to the power of 2, this is equal to 4. 2 to the power of 3, this is equal to 8. So notice how for every added power, the value is doubled. So we start with 2. The 2 times 2 is 4. 4 times 2 is 8. So the next one, that's going to be 16. And 16 times 2 is going to be 32. And as you notice, 2 to the power of 5 is 32. So now if I replace 32 to the power of 5, I get 2 to the power of 3 to the power of x is equal to 2 to the power of 5. Now, if I have something in the form a to the power of a is equal to b to the power of b, then this means that a is equal to b. So in this case, if I have something in the form a to the power of m is equal to a to the power of n, then this means that m is equal to n. So in this case, a would equal 3 to the power of x, and in this case, m would equal 3 to the power of x, and n would equal 5, meaning 3 to the power of x is equal to 5. So now, to solve this, I'm going to take the log on both sides. So now I have log 3 to the power of x is equal to log 5. Now, if I have something in the form log a to the power of b, I can actually move this exponent of b to the front of the logarithm. So this is going to equal b times log a. So in the case of log 3 to the power of x is equal to log 5, for log 3 to the power of x, I'm going to move x to the front. So this is going to equal x times log 3 is equal to log 5. Now I'm going to divide both sides by log 3. So then these two cancel out. I'm left with x is equal to log 5 over log 3. Now, the value of log 5, this is equal to approximately 0.698. And I have this over log 3, which is equal to approximately 0.477. So now if I divide these two, my final answer is going to be 1.465. So this is my answer. Alright, so I have x to the power of 2 is equal to 5 to the power of 2. Now, to solve this problem, I actually have 2 different methods. So for my first method, first start with x to the power of 2 is equal to 5 to the power of 2. Now I'm going to be dividing both sides by 5 to the power of 2. So then these two cancel out, and I'm left with x to the power of 2 minus 5 to the power of 2 is equal to 0. Now, to solve something like this, I'm going to be using important property algebra that states that if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is going to equal x, and b is going to equal 5. So x squared minus 5 squared, this is going to equal a plus b, so x plus 5, times a minus b, so x minus 5. So now if I replace this with x squared minus 5 squared, I get x plus 5 times x minus 5 is equal to 0. Now from this, I have two equations. I have x plus 5 is equal to 0, and I have x minus 5 is equal to 0. So now to solve this, let's first start with x plus 5 equals 0. So if x plus 5 equals 0, simply subtract 5 on both sides. These two cancel out, and left with x is equal to negative 5. And now if x minus 5 equals 0, I can add 5 on both sides. These two cancel out, and I'm left with x is equal to 5. Now for my second method, solving this problem. Start with x to the power of 2 is equal to 5 to the power of 2. Now, if I have something in the form x squared is equal to a, how would I solve this? Well, I would first take the square root on both sides, and then I would be left with x is equal to the square root of a, but this is actually positive or negative, because if you square a negative number, let's say negative 5, this is still going to end up being positive 25. So that's why the square root of number has both a positive and negative solution. So now for x squared equals 5 squared, to solve this, I'm going to be first taking the square root on both sides. So now I have the square root of x squared is equal to the square root of 5 squared. So then these two cancel out, and I'm left with x is equal to the square root of 25, and this is actually positive or negative. The square root of 25 is 5, so I have x is equal to positive or negative 5. So this is my answer. Alright, so I have x to the power of x to the power of 4 is equal to 64. Now, the first thing I'm actually going to do is I'm going to take the power of 4 on both sides. So now I have x to the power of x to the power of 4 to the power of 4 is equal to 64 to the power of 4. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. And m times n, these two are interchangeable, meaning this is the same thing as a to the power of n times m. And if I can rewrite a to the power of m times n as a to the power of m to the power of n, then this means that I can rewrite a to the power of n times m as a to the power of n to the power of m. So to put this into simpler terms, a to the power of m to the power of n, this is the same thing as a to the power of n to the power of m. So, for our equation here, I can think of x to the power of 4 here as m and 4 as n. So now, because I can switch these two places together, I'm going to rewrite this x to the power of 4 to the power of x to the power of 4. Now this is equal to 64 to the power of 4. So all I did was I switched the places of x to the power of 4 and 4. Now 64, this is the same thing as 8 to the power of 2. So now I have x to the power of 4 to the power of x to the power of 4 is equal to 8 to the power of 2 to the power of 4. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So a to the power of 2 to the power of 4, that's going to equal a to the power of 2 times 4. and 2 times 4, that's obviously equal to 8. So I have 8 to the power of 8. Now I'm going to let y equal x to the power of 4. So now if I replace y for x to the power of 4, I get y to the power of y is equal to 8 to the power of 8. So now if I have something in the form a to the power of a is equal to b to the power of b, then this means that a is equal to b. So in this case, y is equal to 8. Now remember how we set y equals 4 to x to the power of 4. So now that we know that y is equal to 8, I have x to the power of 4 is equal to 8. Now to solve this, I'm going to be taking the 4th root on both sides. So now these two are going to cancel out, and I'll be left with x is equal to positive or negative 4th root of 8. So that is my answer.